Hello students, welcome to Nilagiri Degree and PG College YouTube channel. I thought you already watched previous videos. In previous videos, last video was stack. First unit, third chapter, stack. Today we will discuss about stack primitive operations. Before that, we will revise what is stack. So we have studied that stack is a linear data structure in which elements can be inserted and removed in only one end. That end is called as a top. So generally, this is a stack. Here elements can be inserted from here only. Elements can also be deleted from here only. So this is a stack. So first, for example, when you insert an element, for example, I say one element inserted, that is A. Again another element inserted B. Again another element inserted C. In this one, the first inserted element is this one. This is second inserted element. This is third inserted element. If you remove any element from the stack, first the topmost element will be removed first. That is, C will be out. C will be out. That means the last inserted element will be removed first. So that we also studied that stack is a LIFO data structure. Last in, first out. Sometimes you can also say that first in, last out. In these three elements, first A was inserted, last C was inserted. If you perform the delete operation, first C was removed, then next B, then A. That means first inserted element will be removed last. So that mostly you can say that stack is a LIFO data structure, last in, first. So today we will discuss what are the various operations performed on the stack. How those operations will be executed. So generally, the basic operations on stack are two operations. One is push, another one is pop. That means mostly we insert the element into the stack and we remove the elements from the stack. We will insert the element into the stack, we will remove the element from the stack. So push means inserting an element into the stack. Pushing means inserting an element into the stack is called as a push operation. See, for example, this is a linear data structure, that is stack. Say for example, the size of this linear data structure is 4. The size is 4, that is n is 4. Say size is 4. That means we can insert the 4 elements into the stack. Here, this is the 0th position, this is the first position, this is the second position, this is the third position. Initially, we have to maintain a element that is called as a top. It will point out the what is the topmost element. It will point out the location of the topmost element. See, for example, if you take this one, A, B. So, what is the topmost element? B. Where is the B? What is the location of the B? So, that is maintained by using the top. Now, this is the star. There is no element in the stack. So, that the top value always -1. Top value always -1. When there is no element in the stack. That means whenever top value is -1, we can say that stack is empty. When top value is -1, we can say that stack is empty. For example, there is an element A in the 0th location, there is an element 1 B in the first location, there is an element C in the second location, there is an element D in the third location. What is the topmost element? D. What is the position of the topmost element? 3. So that means whenever there are four elements, automatically top value is 3. Now tell me whether stack is, can you insert one more element to the stack? For example, I want to insert an element E also into the stack. Can you insert? Is there an empty space in the stack? No, because the size is 4 only. We can store only 4 elements in the stack. Already 4 elements are there. We cannot insert no more element. Okay. How to find out the stack is full? In this location, stack is full. In this situation, stack is full. So because the size of the stack is 4, already 4 elements are there. When there are the 4 elements, what is the top value? 3. That means whenever top value is equal to size minus 1. What is the size? 4. 4 minus 1, 3. Whenever top is 3, we can say that stack is full. We cannot insert any more elements. For example, so for example, size is 9. What do you mean the size 9 is? We can insert the 9 element into the stack. So the first element is at the 0th position, second element 1, like the last element is at the 8th position. So when there is no element in the stack, top value is minus 1. When we insert an element that is stored at the 0th location, top value becomes a 0. When you insert another element, top value becomes the 1. That the element will be inserted in the 1 position, the top value becomes the 1. So whenever we insert the last element that is stored at the 8th location, top value becomes the 8. When the top is 8, automatically stack is full. When the top is size minus 1, 9 minus 1, automatically stack is full. We can say that stack is full whenever top equal to size minus 1. See, whenever performing the two operations, whether push operations or pop operations, we have to check the two things. One, stack is full and another is stack is empty. Simply see, just here this is an empty stack. Now I am performing a push operation. I am performing a push operation and inserting an element A into the stack. Now what happens? What we have to do? First, we have to increment the top value. Size is 4 only. We have to increment the top value. Top value increment minus 1 plus 1 is equal to G. Now insert this new element at the 0th location. This is 0, 1, 2, 3. A. Next, I am performing another operation, push B. 0, 1, 2, 3. Size is 4. Now again increment the top value. 0 plus 1 is equal to 1. Already A is there. 0 plus 1. Now we have to insert the element at the B position. That means to perform the push operation, we have to check first one thing, whether top equal to size minus 1. If top equal to size minus 1. If it is true, we cannot perform stack operation because stack already full. Stack already full. If it is false, we have to increment the top value and assign the element at the top position. Stack floor at the top position, we have to assign an element. So this is the push operation. I am not writing any C language, C++ program. Just I am writing an algorithm. So what we have to do? Only one thing. Before inserting an element into the stack, or before push, push operation, we have to check whether stack is full. For example, simply I told to place a book on a rack. What will you do? Whether you check it is empty or full? We have to check whether it is full. If it is full, we cannot insert. We can say that, sir, I cannot insert another book in the rack because the rack is already full. So that we have to check whether the stack is full or not. When the stack is full, the top value is equal to size minus 1. We can say that stack is full. Otherwise, else, if this condition falls, we have to increment the top value and insert the new element at new top position. So initially top is minus 1. Minus 1 is equal to 4 minus 1. 4 minus 1 is size minus 1. No, false. So that we have to increment the top value. Top plus plus. Top plus plus means plus 1. You can add plus 1. Minus 1 plus 1 is equal to 0. We have to insert new element at the 0th location. Again I perform the push operation. Again size equal to 4. Again top, what is the top value? 0. 0 is equal to size minus 1. False. And incremented the top value and inserted the new element into 1. So for example, the top situation is like this. C, D. Now what is the top value? 3. How can you say? When there is an element at the 0th location, top value is 0. When there is an element at the up to first location, top value is 1. When there is an element up to third position, top value is 3. Now I will try to add another element. I want to perform another push operation E. So what do I do? First check top equal to size minus 1. 3 is equal to size minus 1. Size is 4. 4 minus 1. Yes, top value is 3. Size value is 4 minus 1 means 3. So 3 is equal to 3 as true. So you can say that stack is full. So this is a way of performing a stack push operation. Okay. So just practice itself in the rough notebook. In the next class we'll see about the pop operation. Now let's see how to perform what is pop operation. So pop means removing an element from the stack is called as pop. Inserting an element in the stack is called as push. Removing an element from the stack is called as a pop. So before performing pop operation, what you have to check? Is there something or not? So for example, I said bring a notebook from the trap. What you have to first of all check, is there any notebook is there or not? That means you have to check if it is empty. If there is no notebook in that one, you can directly say that so there is no notebook. If some notebook is there, we have to ask which notebook we have to bring. So similarly, whenever you have to remove an element from the stack, we have to check whether it is empty. Because if it is empty, no need to perform the pop operation. If when stack is empty, no need to perform the pop operation. If it is not empty, some elements are there. At that time, we have to remove the topmost element. That means we have to check first if top is empty. How can you say that when stack is empty? As I told, when top equal to minus 1, we can say that stack is empty. Stack is empty. Else, what we have to do? Now we will see the example. So for example, this is a stack. Size is 4, 0, 1, 2, 3. Here size is 4. So for example, there are 3 elements, say A, B, C. Now you can say that what is the top value? Imagine top wall is 2. Write 2. The elements are filled up to 2. So the top wall is, the topmost element is at the second location. So the top wall is 2. So if you want to perform the pop operation, again you will get one doubt. Sir, in previous written the push, you have given some element name, but you are not giving any element name, because whenever you perform the pop operation, it automatically remove the topmost element only. We cannot remove any element as our requirement, as our desire. You cannot remove element as per our desire. So it will remove only topmost element. It will remove only topmost element, so that no need to give any element. But here you can insert whatever you element. The position will be set by the stack, but you can, the element will be, name will be given by us. But here only topmost element will be removed, so that no need to give any parentheses. Whenever the pop operation, what have to be done? Actually 0, 1, 2, 3. So A has to be as this, B will be as this, C has to be 1. So this is the size is 4. Now what is the top value? 1. C will be out. What happened? Whenever we perform the pop operation, first of all it will check whether it is an empty. What is the top value? 2. 2 equal to minus 1? No. So that it is not empty. Now coming to what we have to do? Simply we have to decrement the top value. So what is the top value? 2. Now what is the top value? 1. What happened? It has decreased. So we have to say that decrease the top value by 1. We have decrease the, first remove the element at the top position and decrease the top value. Remove the element at the top position and decrease the top value. So simply delete top element and we have to decrease the top value. This is a logic for the removing an element. See, for example, this is another example 0, 1, 2, 3. So here size is 4. There are no elements in the stack. So automatically what is the top value? Minus 1. I perform the again pop operation. What happened? Minus 1 is equal to minus 1. Yes, it will be the stack is empty. Actually stack is also empty. So this is a pop operation. Simply. So to perform the pop operation, first of all, before you perform the pop operation, we have to check whether the stack is empty. The stack is empty when top is equal to minus 1. If stack is not empty, remove the element at the top position and decrement the top value. This is a pop operation. These are the primitive operations. In the next video, the same operation, how to write a program. So before going to the program, first of all, we have to know how to represent this stack. Whether it is a linear data structure. Okay, whether it is a static linear or dynamic linear. Whether it is static data structure, dynamic data structure. If it is a static data structure, we can use the arrays. If it is a dynamic data structure, we can use a linked list to represent a stack. So that will be discussed in the next class. Representation of a stack we'll see in the next class. Okay, just write down, practice the push operation and pop operation by taking some elements. If you have any doubt, post in the WhatsApp. Okay, take it.